you want to learn supervised machine learning? If yes, then this course is for you. The course has been designed for supervised machine learning students. The course has explained from all the basics of supervised machine learning and it finishes on a pro level. The real-life examples of supervised machine learning has been added as well to make the course more valuable for the learner. The course includes step-by-step explanation of more than 7 hours video lessons on supervised machine learning, instant replies to your questions asked during lesson, weekly live talks on supervised machine learning. You can raise your question in a live session. Helping material like notes, examples and exercises, solution of quizzes and assignments. In this course, you shall learn applications and importance of supervised machine learning, binary classification, multi-class classification, simple linear regression, multilinear regression, polynomial regression, k-nearest neighbor classification, k-nearest neighbor regression, decision tree classification, sport vector machine, logistic regression, and data visualization. My name is Adi Chaudhary and I have 4 years of teaching experience on YouTube. Almost 86,000 students has been enrolled in my different courses for giving the good feedback. Hope you will join me. So now we are going to start another important domain of artificial intelligence, which is machine learning. And in this course, we are mainly focusing on supervised machine learning. So before starting it, we need to check out what type of things that we are going to study in this course. First of all, in chapter number 1, we are going to learn what is actually artificial intelligence. In this chapter, we will learn how artificial intelligence is working in our lives and how it is making influence in our lives. And after that, in chapter number 2, we will learn about different types of applications of AI in real world. Yes, and after that, our chapter 3 will be started, in which we will learn about different domains present inside AI right now in real world. So after that, in the chapter number 4, we will learn about machine learning. From this chapter, the chapter number 4, we will start working on machine learning. From here, our real work will begin. So after that, we will move toward chapter number 5, in which we will learn about different types or different classifications of machine learning present inside it, in which we will learn about few different classifications of machine learning present in this time. So after that, we will move toward the chapter number 6. So in chapter number 6, we will learn about the supervised machine learning. Yes, the topic of this course. From here, we will start our real working, where we are moving toward the supervised machine learning. So after that, in chapter number 7, we will learn few different algorithms present for supervised machine learning. Yes, we will diagnose all the supervised machine learning algorithm in there and check out how they are working on different type of data sets and which type of outputs they are giving to us to perform machine learning models on our data set. So after that, from here, we are going to start our practical working, where we will get a real-time data sets, and real-time data sets containing too much ambiguities inside it, like they will have duplicate values, the missing values, encrypted values. So we need to fix in it. In this chapter 8, we will do data preparation or data pre-processing, right? So after that, we will move toward the chapter number 9, where we are going to start our real-time working with artificial intelligence and machine learning algorithms present inside supervised machine learning algorithms. Yes, so let's move to our first chapter, which is artificial intelligence. So what is artificial intelligence? As its name telling us, it is the type of intelligence which is produced by using artificial ways, not by the natural ways. Because if you look at the human body, the human brain, it is not artificially designed for any intelligence. Yes, it also requires some experiences and some practices to develop more intelligence inside it. But the brain is not produced artificially, it is produced naturally, and all the processing happening inside our brain is natural. But in artificial intelligence, we are providing intelligence to our machines. So let's move toward its definition. So it is a branch of computer science in which we are making machines able to make decisions on their own and act like human brain by using provided data and past experiences. As I told you, human brains are also developing intelligence by using our past experiences. Just like the human brain, artificial intelligence is also learning from the previous data that we provide to it to train on that specific data. And after that, it will look on their own past experiences, which is an important topic in machine learning, reinforcement learning, where it learn from its errors and do debugging on it. That's the simplest that's the most important topic, but the simplest topic in there that we can learn in machine learning. So after that, computer is also completing many complex tasks in less time, for making decision on chessboard to producing content. Yes, nowadays, but not now for this. From many years back, artificial intelligence has started it working from 90s. So artificial intelligence become that much mature, it is making chessboard decisions on the spot. Like, it is not taking too much time like human beings. They are thinking about which move I need to move for protecting myself or doing chess to other player. So machine is not going to take that much time. It will do every work efficiently and faster than human brain. And nowadays it is also producing a content. Yes, we have a whole picture available on the YouTube, which is all though produced using artificial intelligence. All the dialogues delivered in this picture is generated by using artificial intelligence models. So on the basis of this, the whole movie is made in there. So by these definitions, you can easily understand that by artificial intelligence, what it is doing, it is making our machine intelligent to make its own decision and provide few facilities to us by using our previous data that we put inside in their models. On that model, it train itself, and it can also correct their outputs by occurring errors and debugging inside it, and can make complex decisions on uh, on the spot by using lesser time than humans. How artificial intelligence is going to work? There will be a background from where it is coming, and in which manners it is going to work to give that much efficient information to us. So how it works, a large amount of data is provided to the computer, which is processed with most intelligent algorithms. Yes, the algorithms of artificial intelligence, like machine learning, we have deep learning, and other than that we have natural language processing and computer vision as well, the most emerging domain of artificial intelligence right now, by extracting features from it. As in our data science section, we learn how we manipulate our data. This is just a beginning. As I told you, whenever we are going to do real-time application, you will get amazed. So this is the time you are going to get amazed right now. So what machine is doing? Machine is taking our huge data sets. Dataset is going inside our machine learning, our artificial intelligence, many other algorithms. It will make a prediction by extracting features from it, like the patterns embedded inside it. And after getting patterns from this data, computer is trained on this specific data for performing tasks by giving prediction output on specific inputs. So when we trained our artificial intelligence model on a specific data, it is going to make some outputs. For making output, we need to provide few inputs. These input not be in its the training data set. We will look in our future examples whenever we are going to train our machine learning or any other artificial intelligence model. We are going to provide two different types of data, the training data set and the testing data set. The training data set is quietly different from the testing data set. This is we have resemblance in the data sets, but difference mean not the same values, not the exact values. They are most likely values, but not the exact values. They will be trained on the training data set. By on training on the data set, we are going to check the validation. What mean by validation? We will provide a testing data to it. It will provide few outputs against this data. As I told you, in our training data, we also abandoned some inputs and outputs against few inputs. So just like the our training data set, in our testing data set is same like it. So it will give few predictions on it, and we will compare the training actual prediction and the prediction given by the system. We will compare these two predictions and check the validation accuracy for our machine learning model. And this is how our artificial intelligence is working right now. This is quite simple. Let me explain in few lines. Like, first of all, we are going to give few information to our computer. It will keep training on their data. Whenever we are going to provide few data which is not inside its training data, it will do some working on that data and provide us output according to that input. Yes, this is how our whole artificial intelligence is working right now. So let's move toward the type of artificial intelligence that we have right now. Before telling you about the type of artificial intelligence, it is divided on two separate ways. Like, first of all, it is divided on the basis of its capabilities, how it is capable to do what type of things. So in the second type, it is divided on the basis of the functionalities, what type of functionalities it can perform inside it. So first, discuss about our types on the basis of capabilities inside our AI. First of all, we have narrow AI. Yes, narrow AI is also known as the weak AI, and it is only focusing on one narrow task. One task will be assigned to it. It is not going to work on any other task and cannot perform beyond its limitations. It will never going to cross its limitations. It targets a single subset of cognitive abilities and advances in that spectrum. It is just going to assign, we are just going to assign a single task to it, and it will keep performing its training on that task and become expert of this area only. It is not going to move any other side. We have commonly a few examples present inside our daily life uses of narrow AI. First of all, we have the Apple Siri or the Google Assistant available in there. And after that, we can have a look on IBM Western, and other examples are also present in there, like spam filtering or fraud detection and etc. So how Siri is working in our real life? Siri is just going to take information from us and providing few outputs to us according to our inputs. He is not going to be super intelligent to perform its your mobile or laptop by its own. It is going to do some specific task. It is going to print your videos, making your content. No, it is not going to do that things. It is just going to assist you on the few tasks that you are going to assign to your Siri or the Google Assistant. It is not moving toward any other task like the advanced task. So in narrow AI, we are only focusing on a single task and becoming expert on that specific task. And after that, we have general AI. So what is general AI? It is also known as the strong AI. It is a one step further from the narrow AI. It allows a machine to apply knowledge and skill in different contexts. AI researchers have not been able to achieve strong AI so far. It is not achieved yet, but the scientists are still working on it, but this is the one step further from it. So they are still working to find few methods that will be suitable for general AI, a strong AI. In the simple words, we are telling it the general AI, but it is drawing some few different tasks that need to be done in different ways. The examples of this is the supercomputer that we have nowadays in huge varieties. Every big company like the Facebook, the Google, Amazon is going to build their own super AIs. Also, IBM is working on it. And after that, we have the biggest capability of AI, which is super AI. Super AI surpasses human intelligence and can perform any task better than a human. Yes, just like the movies in which you look a super intelligent human robots that can do any task faster and more efficiently humans. And for a few of them, they are going to make the humans like the prison in the prisons. They become more intelligent than humans, like the Matrix movie. Have you watched it? I think you will. You have watched it in your uh, movies cards. So after that, we are moving toward the functionalities topic, like the which type of artificial intelligence we have on the basis of the functionalities. First of all, we have a reactive machines. A reactive machine is primarily from a form of artificial intelligence that does not store memories or use past experiences to determine future actions. It works only with present data. They perceive the world and react to it. Reactive machines are provided with specific tasks and they don't have the capabilities beyond these tasks. Just like the narrow AI, it is not working any more than it. It is only working their own tasks or the functionalities that are giving to it. So after that, we will learn about the machine limited theory or the limited memory. So in it, limited memory AI trained from past data to make decisions. Yes, this is the one step further. In the reactive machines, they are just using its present data that is provided on the spot. And in the limited theory or the limited machines memory machine, it is going to use its past data and it do some modification by using its own algorithm to do some specific task. They can use this past data for a specific period of time, but they cannot add it to a library of their experiences. Yes, this kind of technology is used in self-driving vehicles. As you can see, the Tesla is the most emerging examples right now, in which they are using the self-driving cars. In here, they are using the limited memory machine learning here. And after that, we have a theory of mind. It represents an advanced class of technology and exists only as a concept. Yes, such kind of AI requires a thorough understanding that the people and things within an environment can alter feeling and behaviors. It can understand people's emotions, sentiments and thoughts, just like the human beings. By their experiences they can judge others, a person's emotions and thoughts, what they are thinking right now. For us it's in a negative or the positive way. Just like that, the theory of mind is still working, and it is the conceptual topic right now, but we are still working on it. The real time example for this is the Sophia. Yes, Sophia is the real-time example for the theory of mind. He can't perform specific uh, functionalities right now, but he's a concept, but doing too well. It is drawing many tasks beyond the expectation because it is not completed yet. It is still in the development phase, but it is actually working, but not in a good way. But it is working fine right now. But we are also studying and doing development and researching on that topic of theory of mind, and it is not going to be in future. It is today, and we will make it in today's era. So after that, we have a fourth type of functionalities of AI, which is the self-awareness. Self-awareness AI only exists hypothetically. Such systems understand their internal traits, states, and conditions and perceive human emotions. These machines will be smarter than human mind, and this type of AI will not only be able to understand and revoke emotion, in those it interact with, but also have emotions, needs, and belief of its own. Just like the super AI, but this is little advanced from them. You can make the resemblance on these capabilities and the functionalities type. Narrow AI is working on the reactive machines, and general is working on the limited theory and theory of mind. You can compare it like that. This is not the actual, but you can do it like that. The super in AI is working with a self-awareness. They have resemblance in them. So let's move to the next topic, and which is going to be like the applications of AI. In real world, we have too many examples of applications of AI in real world. First of all, we will discuss about the e-commerce. In e-commerce, we are actually using artificial intelligence. The first of them is like the personalized shopping. You have noticed that whenever you search a specific product in a browser, it is going to make suggestions according to this specific product in your feeds page and or the home page. You might be interested in it. This is the type of the specialized personalized shopping in AI. And after that, we have education sector available in there. Although the education sector is one most influenced by humans, artificial intelligence has slowly begun to seep its root in the education sector as well. Even in the education sector, this slowly transition of artificial intelligence has helped increase productivity among faculties and help them concentrate more on student than office or administrating works. Yes, it is taking the place of administrative tasks in education sector, and the instructors are most likely to be focused on their students. First example, we have the administrative task automated to aid educators. And after that, we can make the smart content by using our artificial intelligence, as I told you in the definition of artificial intelligence. And after that, we have the voice assistants. We just going to tell them by using our voice, do this task. He is going to do this task, and we don't need to worry about it or put any extra time in this specific task. And the personalized learning is also a topic inside our education sector in AI. And after that, we have most applications in lifestyles of AI. First of all, we have the autonomous vehicles. Yes, automobile manufacturer companies like Tesla, Audi, Volvo, and Tesla and Toyota uses machine learning to train computer to think and evolve like human when it came to drive in any environment and object detection to avoid accidents. Just like the self-driving car, it is training them to drive their cars by their own self. A human don't need to drive it, and it will predict every condition more efficiently than human and make prediction on its driving. And after that, we have the spam detection in lifestyle. Whenever you are going to do online transactions or clicking on any link that is infected by some virus or malware, it will detect it by using spam detection inside it. Even in our emails, it's we have a folder of spam emails where it filter our emails in the spam area and going to store it in a separate folder where we are not going to access them directly or by clicking on their link. We can be get infected. So this is how spam filtration is working in our lifestyles by using AI. And after that, we have the facial recognition is the most commonly using example for right now in our mobiles or in security sectors. We are using facial or iris scans. By using them, we can do our security maintenance by just using AI. The most and huge application of artificial intelligence is in the robotics sector. Robotics in another field where artificial intelligence applications are commonly used. Robots powered by AI use real-time updates to sense obstacles in its path and pre-plan its journey instantly. We will learn how we can make different types of algorithms and train our model to train a robot to do its task. For example, you put it a self home cleaning robot inside your house and it is going to clean your floor. Whenever it takes some obstacle inside its way, it will change its way, but it is considered to complete its cleaning of whole floor. So it will make as paths by using it intelligence, real-time intelligence, and it will make few decisions on it and make its own way to do its specific task. So after that, just I told you, we can have self cleaning floors and the self cleaning offices and houses, robots. After that, we can carry goods by using them. In our manufacturing plants, we are using too many types of robots that are actually doing their stuff by own. We don't need to put the human efforts inside there. They are doing more efficiently and correctly everything than human in a fast and efficient manner. And after that, we have a huge application in the health and care industry. Using artificial intelligence, we are making too many algorithms and machines that can detect automatically diseases in human body. Just like the cancer detection or the tumor detection algorithm that we have designed, they are designed in that way they can easily detect that in which session or which part a human have cancer inside it. A cancerous cells or the tumor cells, they can easily detect by using AI. And we are still working in there, and regardless these, we have too many different applications of artificial intelligence. We are using it mostly in our fertilizers and our industries of gaming, agriculture, and after that we are using it in every aspect of life. Whatever you are not familiar with that, but in that place we are using our artificial intelligence. Even in our YouTube, you can also check that the recommendation system in Netflix also, they are also using smart AI for doing working on it. So let's move toward our next topic, which is domains of AI. So artificial intelligence is divided into different domains for right now session. Now we have 5 different types of domains present inside artificial intelligence right now. So it is divided into 5 sector. First of all, it is the subdomain is machine learning, and after that we have deep learning, and after that we have data science, computer vision, and natural language processing. Data science is the most hottest field right now, right? So what is actually machine learning? In this subdomain of AI, we are going to use our historical data. Yes, we use our historical data and put inside different algorithms which are going to make some processing on it and simply providing us outputs against these data. So machine learning is the most basic, and it is using in huge range in our daily lives, like spam detection, some making predictions, weather predictions, stock predictions, everything from classification to regression. We are using machine learning inside it. In machine learning, we have different algorithms like SVM, we have regression algorithms, and we have classification algorithms present inside there. We can also can do image classification by using machine learning. After that, we have a next type of a domain, the subtype of the artificial intelligence, which is deep learning. In this, we are mostly going to use artificial neural networks. Yes, just like our human brains, we have some neurons inside it, and we flow our information in these neurons in that efficient speed. It is passing from different neuron, different nodes, and collecting some information to give some outputs. Like whenever someone is going to ask about us, our brain will interpret it in millisecond, right? And it is going to give outputs against it. So this is how our deep learning is working, in which we are finding different patterns, adjusting the weights to more precisely give outputs to our machine learning or deep learning models. So after that, we have the data science. Whenever we get the data, it is in the form of raw. In the raw form, we are not going to take any information from it. As the research in last 2 years, the human gets 90% of its whole data. the data that is present in our labs, like the biggest data science laboratories, the 90% of the data is of just last 2 years. So you can assume that how emerging and hot field of right now is data science. So in data science, we are just taking a few patterns and information from our raw data, like we are removing noise, we are correcting our data, finding missing values, and all these ways we are doing data science in artificial intelligence. After that, we have computer vision in artificial intelligence. You can see it is the eyes of AI, eyes for our computers. Every task that artificial intelligence is going to do by visuals, by containing inputs as videos, images, or the visual, any type of visual inputs, this is going to be inside of computer vision. In computer vision, we can detect our different objects, we can compare different images, we can find a specific human or specific objects inside a single frame. We can also do it on the specific videos. And right now it is also emerging and a too hot field in there. We are mostly using in security surveillance and fraud detection and intrusion detection. These are the hot topics in computer vision. After that, we have the natural language processing. If a computer is interacting a human language, it is going to use natural language processing subdomain of AI. Yes, in this subdomain of AI, we are going to deal with natural language. Have you ever take assistant, Google Assistant or Siri? What it is doing right now? It is taking command by our voices. It extract meaningful information from it by using data science, and it is going to work in it. Natural language processing, data science, computer vision, deep learning, or machine learning, they are most likely working with another. Let's take an example of Sophia right now, the humanoid robot present in the world. First of all, what actually it is doing? Can you see the eyes? These are the cameras inside it in head. Eyeballs are the cameras. Like they are using the computer vision in there. It is taking inputs as the visuals, and what it is doing some operations on it to extract some objects, extract some personalities, rather it is known or unknown, and after that it is giving this information to our data science session. What this data is going to do? This is going to do remove it noise, clarify this data, and by clearing this data, it moves toward a specific sector like machine learning. It is going to use some figures like I'm going to ask the Sophia what is time right now, right? It will extract some keys from it, time right now, so he need to tell me the time for now. Data, clean that data and give some keywords to the machine learning. What it is going to do, it is just going to do some regression to put regression algorithms on it, and after that it is going to give me output which is going to be the time for right now to me. These are just the simple examples. Not these commonly or easily it's working in artificial intelligence models. There are too many processing inside it, but for just your learning to giving you an assumption, I'm telling you this. If someone asks them a complex task, it will move toward the machine learning and deep learning. It will do some neural network, use some artificial neural networks to do processing, adjusting it weights and adjusting it output, and it will provide us output. So as I told you, I'm asking for time to Sophia. So how he can recognize what I'm telling? So in this sector, he is using natural language processing. It will use their sensors to mics installed in their head. He will use it to interpret this information and check what I am telling and how will machine understand that language. These all the fields that are working with each and other to produce a great artificial intelligence models in our real life. So these are the fields available inside AI. So in this topic we will mainly focusing on the machine learning section, where we'll learn what is machine learning, what are the subdomains, are the classification for the machine learning, and how he is doing with our data. And after that we are also touching our data science, because we need to prepare some data sets for doing working on our machine learning models. So let's move to a topic which is the machine learning. So what is machine learning? Machine learning is the branch or the subdomain of artificial intelligence in which it focuses on the uses of algorithms and data sets to imitate the way that humans learn and gradually improves its accuracy. It is just going to use our historical data that we provide to its models or the algorithm. It will keep training on it to achieve the accuracy which is necessary for producing efficient outputs to us. So what it is going to do? It is just going to take the historical data, do training on it, and provide us like the outputs from it. It is an important and growing field of AI and data science. By using statistical method and algorithms, it trains models for classifying or prediction. Mainly two type of things we are doing in machine learning. One is the classifying, and second is prediction or regression, you can say. Two main things inside the machine learning is classification and regression in there. And after that we have SVM or K-mean also embedded inside it, but mainly we are focusing on classification and regression in machine learning. So how machine learning works? It is important to learn how machine learning is going to work step by step. Step is decision process. In general, machine learning algorithms are used to make a prediction or classification, as I told you in previous slide. So based on some inputs and outputs which can be labeled or unlabeled. I told you in previous examples and slides, we are providing two different types of data, the training data set and the testing data set. These can be labeled or unlabeled. Your algorithm will produce an estimate about a pattern inside this data by using this data which is labeled or unlabeled. For now, we are not moving in advanced topics. You just need to check that we are simply providing few labels data. Labels data mean if we have inputs, we have the outputs against this data for a model training. So after that, the second step is error function. An error function evaluates the prediction of the model. Yes. And if there are known examples, an error function can make a comparison to assess the accuracy of the model. Just I told you in the previous examples, whenever we train our model, what it is going to do? It will produce some outputs against input values. When we divided our data set into two sectors like the training and the testing data set, in the training data set we have few inputs and outputs. The model will keep training on these data. It will train like if the inputs are like this, I need to give the output like this, if this and this. Just like that, it will keep training on the whole training data set that we provide to our model. And after that, we need to use our testing data set for its testing, for finding the validation, to doing validation on our model by using this data. What we are going to do, we will use this training data. We provide this training data's input and outputs to the machine learning model. What it will do, it will only use the input values of this testing data set. This will give these inputs to our trained model that is trained by using training dataset. It will generate few outputs against this testing datasets inputs. The outputs generated by model and the output that is actual outputs against this testing data will be compared inside our model. When he will compare, for example, it will build three columns. Actually, it is not going to build three columns. For just your understanding, I am telling you, it will build three columns. One column is the inputs that we give from our testing data set. After that, it is the actual output and the predicted outputs. It will compare that if input from this first row is this, and against actual outputs this, and the predicted output is this, it will compare all three columns and check how much accuracy it gained. Like the input in our first column is 5, in the second output we have 10, and the predicted output is 9. There is a difference of 1 point. So it will calculate the accuracy between these points and tell us what accuracy is achieving our model. So in this way, it is just calculating the validation and accuracy of our model. After that, we will move toward our third step, which is model optimization. If the model can fit better two data point in the train set, then weights are adjusted to reduce the discrepancy between the known examples and the model estimate. The algorithm will repeat its evaluation and optimization process, updating its weights autonomously until a threshold of accuracy has been met. Just I told you, for example, we need a threshold, like we need 85% accuracy from this model. First of all, we trained it in the first time, it gave us 65%, but we need 85%. It will retrain itself, it will keep retraining itself until it achieves the accuracy of 85%. It will achieve our threshold for model training, because we don't want any miss or encrypted values outside our model. So for that purpose, what we doing, we are retraining our model again and again to achieve the accuracy that we need from it. For example, I'm going to ask what is the time right now. Right now the time is like 23:15, and it is going to tell me 25:15. So this is not the correct time. So that's why we need to maintain its accuracy by retraining the model again and again. This is the model optimization. So let's move to the next slide, where we will check about the classifications of machine learning. Four different types of classification in machine learning: the supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement machine learning. First, we will discuss about the supervised machine learning. It is also known as supervised learning and is defined by its use of labeled data set to train algorithms to classify data or predict outcomes accurately. As input data is fed into the model adjusts its weight until it has been fitted approximately, like it can attain its threshold. This occurs a part of the cross-validation process to ensure that the model avoid overfitting and underfitting. These are the also most important topics inside machine learning, which is of overfitting and underfitting, that we will learn in our future, how we can maintain these values to attain a maximum accuracy in our models. Supervised learning helps organizations solve a variety of real-world problems at scale, such as classifying spams in a separate folders from your inbox, just like the Google Mail and even the Outlook mail. They are doing, they are separating our spam messages and the real-time messages in separate folders. So this is how supervised machine learning is working inside there. We have different types of algorithms present inside there, which we will learn in our further slides. Then we have unsupervised machine learning, and this is also known as the unsupervised learning. We are just missing the machine from it. This uses algorithms to analyze and cluster unlabeled data. In this session, we are moving ahead toward unlabeled data, right? So these algorithms discover hidden patterns or data grouping without the need for human intervention. Humans are not going to integrate inside it, uh, just like we are not providing any labels to them, and it is going to find hidden patterns in data by their own self and doing model training on it. It is also used to reduce the number of features in a model through the process of discriminationally reduction. Principal concepts of data analysis and singular value decomposition are two common approaches for this. Other algorithms used in unsupervised machine learning, which are the neural networks, k-mean clustering, and probability clustering methods. Most of the time, we are doing the clustering type of things inside our supervised machine learning. For example, we have uh, different data, like I have 100 peoples inside it. A few of them are Asian, few of them are European, few of them are Africans. So unsupervised machine learning is going to find a few resemblance inside it, like the color traits, the languages, and the heights, and the hair color, eye color. It will get these all hidden patterns by their own, and it will compare all the people against it, and it will divide everyone according to their region. Like he will going to put in a separate cluster of Asian, a separate cluster of European, and a separate cluster of American and the African. It will divide it into the four clusters. That this is why I am using the term clustering. The algorithms are also named by using the cluster, like the k-mean clustering and probability clustering methods, and the neural networks is mostly used inside this unsupervised machine learning. After that, we have the semi-supervised machine learning. Semi-supervised machine learning offer a happy medium between supervised and unsupervised learning. This is lying between the supervised and unsupervised machine learning, and this is a new classification right now. During the training, it uses a smaller label dataset to guide classification and feature extraction from a large unlabeled dataset. Yes, in supervised we are using only labeled data, in unsupervised we are using unlabeled data, but in semi-supervised it is going to use few labeled data to guide its unlabeled data. This is the best case here. If I told myself Asians or Indians are mostly speaking Hindi, the Americans, the US persons are mostly speaking English, the UK's persons are mostly speaking English, then it is easy for me to classify these further pupils that is lying inside a group. So this is how semi-supervised machine learning is working inside it. Semi-supervised learning can solve the problem of not having enough labeled data for a supervised learning algorithm. It also helps if it's too costly to label enough data. If you are thinking labeling of data is easy task, then you are wrong. It is the most hectic and the long time to label a specific data in there. Whenever you are going to do object detection, we have a smart model present in right now, which is YOLO. And right now we have YOLO v7, v5, and v3 also present in there, which is the old models, versions of this model. Before doing any classification, yeah, object detection in our frames, you need to label your data frames first. Whenever you're going to do data labeling one by one frame, then you will understand how much hectic this labeling processing is. So that's why we are reducing the labeling cost in semi-supervised machine learning. So in the last we have reinforcement machine learning. Reinforcement machine learning is a machine learning model that is similar to supervised learning, but the algorithm is not trained using sample data. Yes, we are not going to use the sample data to train our model. This model learns as it goes by using trial and error. As I told you, we have advanced levels of machine learning, so reinforcement is one of them, in which it is going to learn from trial and error. A sequence of successful outcomes will be reinforced to develop the best recommendation or policy for a given problem. So these are the all four classification for the machine learning right now, in which we are using different ways of data and in different way to take our outputs. The motive for using the machine learning is only we want some prediction, we want some classifications outside it. We need accuracy against it, and we will do everything that we can do to attain that accuracy. So for attaining that accuracy, we are using different types of classifications against different data sets or different type of data to do our tasks. So let's move toward our next slide, which is the trends in machine learning. So now we will compare about how machine learning is emerging in right now nowadays. So we have three things: the supervised machine learning, unsupervised, and reinforcement learning. The use of supervised learning is becoming slow in right now because we have other advanced things in machine learning. Like unsupervised, we don't need to provide any type of label data, but it is giving us good accuracy against it. And after that, we have reinforcement machine learning, which is the greatest approach for right now. So semi-supervised is also must need to be included, but it is not too much emerging because it is a new trend in there. So if you look at the graph in 2018, we are mostly using the supervised machine learning, and we are not mostly focusing on the reinforcement, but day by day when it is going to be developed, it is the use of it is going to be increasing to about 79. Right now we are using about the 79% of the machine learning uses are done by using reinforcement learning in there. So let's check what is supervised machine learning. Supervised machine learning is a type of machine learning in which we uses the labeled data set to train algorithm to classify data and do prediction accurately. In this type of machine learning, input is fed with its output, model adjusts its weight until it matches the approximate result. As I told you in a previous slide, what we are going to do, we are going to provide a few labeled data, not the few, it can be in millions. So we will provide this labeled data to the machine. It will train on that specific data. And against that, we have a threshold for our accuracy. It will keep training itself until it can't approach its threshold accuracy value. So for that purpose, it is keep adjusting its weights, like how many volume of column A and how many volume of column B I need to be used in our models. So this is how we will learn about the backend processing of these all algorithms, how they are adjusting their weights to attain approximate results in our machine learning models. So we have different types of algorithms present inside supervised machine learning. One of few of them are listed there. First of all, we use the classification. Classification is uses an algorithm to accurately assign test data into specific categories. It recognizes specific entities within the dataset and attempts to draw some conclusions on how these entities should be labeled or defined. So it is just going to classify simply things. For example, you need to classify your class. You are a machine learning student. You need to move toward the machine where they are doing programming, telling us about how we can automate our tasks, how we can put human-like abilities inside our machine. You will classify this class easily by checking their traits. You are not going to move any other side. So this is how you can classify. You can use classification algorithms inside there. For classification, we are commonly using the support vector machines, the decision trees, k-neighbor, nearest neighbors. So further, we have regression in there. Regression is used to understand the relationship between dependent and independent variable. It is commonly used to make projections such as for sales, revenue for a given business. In this regression, we have the linear regression, we have logistic regression, and polynomial regression also present inside there. So let's check what is our logistic regression in there. While linear regression is levered when dependent variables are continuous, logistic regression is selected. When the dependent variables are categorical, that means they have binary outputs such as true, false, yes, no. While both regression models seek to understand relationship between data, logistic regression is mainly used to solve binary classification problems. Whenever you are facing a binary classification problem, you are going to use your logistic regression in there, right? So after that we have the k nearest neighbors. Yes, k nearest neighbors, also known as knn algorithm, and is a non-prometic algorithm that classifies data points based on their proximity and association to other available data. So it will check the nearest data around it, and we will provide a k value inside this algorithm, and it will check what associations are happening to closer to me, the nearest to me, and it will going to do the clustering type of stuff inside there. We will learn them in explanation way, and we will do some implementation on it our future workings, like in whenever we are going to implement our machine learning models in real time. So after that we have naive Bayes, which is a classification approach that adopts the principle of class conditional independence from the Bayes theorem. This means that the presence of one feature does not implicit the presence of another in probability of a given outcome, and each predictor has an equal effect on that result. There are three different types of naive Bayes classification, which is multinomial and Bernoulli and the Gaussian naive Bayes algorithms that we will learn in our supervised machine learning. So after that we have the random forest also available in there, which is a random forest and another flexible supervised machine learning algorithm, which is used for both classification and regression purposes. So this is the most advanced topic inside machine supervised machine learning, where we are doing the both things at a time, like the classification and regression on the spot. So the forest references a collection of uncorrected decision trees, which are then merged together to reduce variance and create more accurate data prediction. Yes. So after that we have the SVM, which is the support vector machine. It is a popular supervised machine learning model nowadays. For the it also used for both classification and regression type of things. Just like the random forest, it is also using two different methods to do classification and regression on it. We will learn in their own section in a deep manner. So after that we have neural networks. And neural networks, what they are doing, they are making some decision by processing information from different nodes and different layers. uh, Deep neural networks are lying inside our deep learning, but here we have little neural networks, from where the values are passing through different nodes and predict outputs according to their weights. We can also adjust their weight by their own needs to set the accuracy threshold, or if I want some different type of output from it, I can also change the weight of specific features inside it. So now we will start with our classification and regression processes, and we will learn how we can do classification and regression inside our supervised machine learning, and those other algorithms are providing on facilities of classification and regressions inside it by using some different techniques and algorithms. So we will learn them in detail and deep dig inside these algorithms, how they are working in their background. So first of all, before moving on these algorithms, I need to tell you some real-time uses of supervised machine learning. First of them have image and object recognition. Yes, we can do image and object recognition by using our supervised machine learning. So after that, we have another real-time use, which is sentiment analysis. We will take our Twitter's API, in which we will take data set from our Twitter API and do sentimental analysis on it. After that we have predictive analysis, like the stock prediction, the weather prediction we are using by using this real-time predictive analysis. And after that we have spam filtration, the commonly used example inside our Google Mail, our Hotmails are in our Outlook mails. What they are doing, they are using the previous data present inside there, or they can use the unsupervised machine learning methods or the semi-supervised machine learning methods to develop that type of algorithm that can easily detect the spam inside a text or any other object, and they can separate it from the real content. So these are the few real-time uses of supervised machine learning in this topic. So now let's check what type of algorithms of supervised machine learning we can use for classification purposes and the regression purposes. First of all, we will learn it about the classification, how many types of algorithm are supported for classification in supervised machine learning. So let's move toward our diagram. First of all, we can see we have a block of supervised machine learning in which it is dividing it between two different algorithm types. Like the first one is the regression and the second one is classification, right? So after that, as you can see, whenever we are going to perform supervised machine learning, first of all, we need to provide some data with correct labels with them, from which label the machine is going to be learned for their future predictions, right? So after that, we can see we have classification and regression. For that time, we are looking for classification, and we will check what type of algorithms the classification supported in supervised machine learning. So first of all, as you can see here, we have three different algorithms which is bounded under a line in which you can see we have three different types like KNN, the decision trees, and the neural networks. These three types of algorithms are going to be used with both like regression and classification. As you can see, it is also pointing toward the same block, and the classification is also pointing toward the same block, which is KNN, trees, and neural network. So after that, the specific we have the SVM and the logistic regression as well there. No matter its name is regression, but we are using it for the classification purposes in our machine learning projects. So as you can see, which type of algorithm are going to be supported with classification, you can check out these five names. First of all, we can use KNN for it, which is the k nearest neighbor, and after that we can use decision trees, and after that we have neural networks. These are also used inside deep learning, but in their deep learning we are using deep neural networks. In here we are just using 2 or 3 neural networks inside there. So but when we move to the deep learning, where here we will using hundreds, even too many like deep neural networks are present inside deep learning. So after that we will learn about the SVM, the fourth algorithm which is supported with the classification in the supervised machine learning is SVM. So after that, the last algorithm which is going to be used in our classification in supervised machine learning is logistic regression, right? So as I told you, these three are going to be used with both because they are providing different functionalities with them to perform classification and regression problems solving also. So after that, let's move toward the regression. As I told you, in our regression we can also use different type of algorithms, but here there is a change. We can't use SVM and logistic regression for our regression problems, right? The flow for this regression is same as the classification. First of all, we need to provide the data which is provided with the correct labels to the model, and after that model is going to learn from this already labeled data, and after that, looking towards that examples, machine is going to predict its outputs just looking for its historical data. So as we can check in the regression, we have the linear regression as well. The regression also supports too many types of regression like linear regression. We have multi-class regression, and we have simple linear regression. After that we have polynomial and too many other types available for regression inside it. So after that we can use our k nearest neighbor for regression purposes also, and after that the decision tree is also working there for regression to give outputs to us. And the last we have neural network, which is going toward our regression task. Whenever we start with the deep learning, you will get more familiar with the neural networks. Here we are just discussing a little part of the neural network, where we are going to use few nodes and the few networks inside here, few layers of network, right? So let's move toward our next slide, which is about the classification. First of all, we need to learn about what is classification. The classification is a concept of machine learning, and it categorizes input data on the basis of different classes. A label data is provided to the machine for its training. After that, model will give prediction on that inputs. So how you can understand what classification is? First of all, I want to give you an example, like you want to compare two fruits. One is the banana and other one is the apple, right? I provide you 10 apples and 10 bananas to you. You will analyze these in their what type of features you are going to analyze in these fruits. First of all, you will look at the color of this. Apples will be in the golden color or the right color in there, but in the banana you can see yellow colors only, and after that a little bit shade of the black also. So you will analyze these tell all bananas, and you will look toward their shape, how they taste like and how they look like, what are the color of these banana are there, and after that you will analyze the apples present to you, what is the shape of it, what is the eating procedure, and what type of taste it is giving to me. And after few time you will able to classify which type of thing is going to be like which. You are just a new learner. For example, you are putting yourself inside the machine, like you are the machine right now. You don't have much intelligence right now, but you are doing a classification, just only two things. First is the banana, and other one is the apple. So I am giving you a few apples and banana to do analysis on it. You will same the features from these two classes. After that, I am going to give you another type of fruit, which will be either a banana or an apple. Whenever I give you these products, you will analyze that the features, you will extract the feature out of it, and you will predict this is a banana or this is an apple in there. But if I provide you another thing, like I am giving you orange over there, you are going to be a bit confused over there. But here you will look after a few features. What is the shape? What it looks like? It is looking like an apple, right? So most probably you will declare it as an apple. So here our problems are coming. So we will check out how we can fix that type of problems in our machine learning. First of all, check about the flow of working of classification in supervised machine learning. First of all, what we are going to do, we are simply going to provide a data, which is the label data, as I told you in previous slide. The data is going to be toward our classifier. What is classifier here? Classifier is a specific type of model, or you can say algorithm, which is going to work with that specific data. And after applying this algorithm on this data, our model will become prepared. We have trained our model over here. So how it is working like this? First of all, it will give some data. Data will move to the classifier, where classifier do some analysis on it, and according to their behavior, the algorithm's behavior, it adopt itself according to this data's functionalities, and extract the feature outside of, right? And after applying everything that it is responsible for, it will make a trained model. Like I'm giving you a few examples over there and giving some data to you. You are become trained for that specific task. So the preparation after that, you are coming as a product, you will be a trained model here. Like I'm teaching you for cricket, for 1 year I'm giving you a practice on the cricket, you are become able to play in national level. So this is mean you are a prepared or trained model over there. So now I'm putting you in real life, like the input here. So I am prepared you in the year. Now you are going to check what my preparation is paying me back. So after, for this purpose, I am giving you some inputs, the random inputs. These input most probably not going to be the data which is inside our labeled data that is provided at the training purposes. So after that, I will provide you some testing data which is not going to be familiar with our trained data, like, right? So after that, it will move toward our training model. What now our training model is going to do, it will check out every feature inside input data and provide us classification on that data. Just like the example I given to you, we need to check what type of fruit it is. You classified in that data. We have two different type of classes like fruit and apples. You have thousands of photos of apples here and thousands of photos of bananas here. So it moved toward our classifier, and classifier learned all the features outside it, and after that it prepared our complete model which is going to do prediction on unseen data, right? So after that, we are going to provide few images to a trained model, and it will give us the prediction according to their features present inside there. Is it going to be an apple or a banana, right? So let's move toward our next slide, which is going to be the types of classification. Just like other algorithms, we also have a few different types or the classification of uh, classification, right? There are mainly three different types of classification in supervised machine learning on the basis of their outputs. Just as I told you, first of all, we have the binary classification. What binary classification is going to do, the example that we are taking for banana and apple is going to be the type binary classification. And after that, we have multi-class classification, when we have multiple types of classes present in there like banana, orange, apple, and some other fruit over there. And after that, we have multi-label classification, right? So let's move toward what is binary classification. It is the simplest type of classification in supervised machine learning. Yes, the simplest one. The data provided for model training contains only two classes as output against our inputs and return the result in true or false format. Yes, as I told you, we need to provide only two classes over there. Like we need to compare between is the gender is girl or boy. So we need to provide few data which is going to be having two type of classes only. First class is the boys and the second class is the girls. Just like that, we are going to provide two different type of classes, like one data set is containing only boys images inside it and the boys classifications in there, and after that we have a different data in which we have only photos of girls and their classifications and the features that we need to classify their gender. So these are not going to be the two data sets. It is it is containing inside a single data set but having two different classes. Whenever we are going to do our real-time working, you will get it in a more good sense how it is working. So after that, we will move it toward our classifier. We can use different type of classifiers. It can be like KNN. We can use logistic regression, the decision tree, and these all type of algorithm that are present for binary classification in our supervised machine learning. So after doing after applying classifier on that specific label data, our model will be become prepared for doing prediction on any unseen data. So now what we do, we will give a random photo or the random classifications values to our model to predict which is it. Who is it? It is a girl or a boy. So the model will do some operations on it, and after that it will give us result. The result is going to be like 1 or 2, yes or no, true or false. I'm asking to the model, is he a boy? It will tell me yes or no, true or false, 0 or 1. 0 mean not and the 1 mean yes. So these are the only two type of answers the binary classification is going to give us. The first is the class A. The class A can be true or false, and if class A is giving us true, then class B is going to be provide us the answer false here. So just like the class A and class B, it will tell us in class A it will tell us the boy, in the class B it will tell us the girl, and it is going to give only one answer over there. The answer will be from class A or class B. Both the answer is not going to be given to us in any condition. It is not telling us it is a boy, it is a girl. It is telling us only one thing, the boy or girl. It is giving only class 1 or class 2. So let's move toward our multi-class classification. So it is a type of classification in machine learning in which the data set is based on more than two classes. Just unlike the binary classification, we are using here data which is containing more than two classes. Okay, on the behalf of which we are predicting multiple classes by using our model. Just like the binary classification, the procedures are going to be the same, but here we have a difference in which we are getting too many classes except two only classes. Like we are not going to predict only it's a boy or girl, it can be a transgender or something else, right? So after that we will provide first of all we will provide our label data to the classifier. The procedure is the same for all the algorithm. First of all we are going to provide the data set, because in supervised machine learning we are giving them the data to the algorithms to do predictions on the basis of this historical data, right? It is not going to create any classes, any labels from himself. What it is using, what we are providing to it, right? The first of all label data is provided to it, it containing multiple classes inside there, not only two, it can be 3, 4, 5 or 100 of classes present inside there. So after that the classifier do operations on it, and after that the classifier generate a trained model which is going to give us the prediction, right? Here I want to add one more thing. Whenever we are going to train our classifier, it is a huge time taking process, right? If the data set is increasing, the time for doing the to training a model is going to be increased. So whenever we train our model, we can save this model for our future uses. We will learn it in our practical example how we can save our model for future prediction to save our time. So after that we will provide few inputs here, and how many types of classes are present in our data which is it trained for, it will tell us one of them. It is going to be like class 1, class 2 or class 3, right? So it will like I'm taking the example of fruits over there. We put it 5 different types of fruit in our data, and whenever we are going to provide an image, an unseen image, it will give us prediction against this data. Only the classes which is provided inside the data, the one of them is going to be the answer of it, right? So let's move toward our multi-label classification. So what it is actually, it is also working like the multi-class classification, but here we have a difference. It refers to those type of classification in which we need to predict multiple classes for each example. In the process of image classification, we have different objects present inside each frame. We can do classification of each object inside it. So how actually it is going to be work? We are going to provide the hundreds of classes inside it, and like we want to do object detections inside a video or a picture. So it is not going to give us only one prediction in that. For example, I have a frame inside which we have a person, we have a table, we have a chair, we have a street lights, and other information also inside it. Whatever the class is I trained for it, it will tell me each class present inside there. In our previous examples, it is only giving us one answer, but in there it is telling us multiple answers in there. For example, we have a picture, as I told you, in which we have person, table, chair, street light, the street over there. So it will label each and every item that it know inside it model. It will tell us about it. what is the output going to be as, like in this frame it will label each product that he knows, like he will print it, it's a boy. Another thing is placing like the girl. Here we have a table, we have a chair, we have street light, and the food corner also over there. So it will tell us each and every detail he knows inside a specific frame. It is not going to put a single output from it. So this is the most common difference between our three type of classification that we used in our supervised machine learning to do prediction classification on specific data. So let's move toward our regression. What actually regression is? Machine learning, one, the output variables is real or continuous value. The output can be weight or salary. Regression is basically estimating the relationship between dependent and independent variables. So what actually regression is doing, in our previous examples of classification, we are taking the care of only few classes. Like it is going to give us the result like apple, banana, or cake, or bicycle, chair, table, what else it is. It is specific inside a specific class. It can be declared inside a specific class, but what if we want some other type of predictions from it? Like we want to check out the weight, we want to predict the weight of a specific human, like what is its gender, what is its height, what is its age, and what is its waist. And after being collecting these information, we can judge out what is going to be the weight of this person. And just like the salary, we are going to check out how many years of experience he is having inside the specific field, and after that what is her qualifications, how he is studied in his life, and what type of project he has already done in his life. And after looking these information, we can decide its salary, what type of salary and how much salary is going for this person. So in this regression, we are basically only checking the relationship between different features present inside our data, and after looking at features, after doing modification and doing analysis on these features, we can easily predict an output against these features. So how it's actually working in there, as I told you, in every machine learning, supervised machine learning, first of all we are going to provide a labeled data to our model that is going to work for us. For now in the regression, what we are doing, first of all we are providing a labeled data, right? It is for example, it is telling us about the weight of the person. First column is containing the height, the second column is containing the gender, the third container is taking the age, and the fourth column is containing some other value. And looking toward these four columns inside a table, we are going to predict our output. But whenever we are going to provide the data to our regressor, yes, in regression we are calling it the regressor. Regressor is nothing but the algorithm or the model that we are going to use for our model training. Yes, and after that it will move toward our regressor and do some analysis on it according to its functionalities and the operations we provided inside that regressor, and it totally depends on the algorithm that we are going to choose for our prediction. And after that it will tell us a trained model of what it is going to do. It is going to provide us the output according to our inputs. So now for example, I want to check out the weight of the person. So what we will do now, we need to provide the information. What type of information it is going to ask from us? First of all, it will ask for the gender, and after that it will ask for the height, after that it will ask for the age and waist size, right? These are all the features that we use for training purposes in our data set. So it will ask for these features, and after looking at these features, it will compare it in its historical data, which is stored in our trained model. So after looking at it, doing analysis on it, and it will provide us a value. Value is not going to be like the fat or flat. No, it is going to be a number, a continuous value, a real value over here. So after telling us, for example, the person's age is 20 and his waist is like 40, and after that it is going to check the gender is man, and after looking these values, it is providing us information like its weight is 70 kg, right? So this is how regression is going to be work. For example, we change few values over there, and what it is going to do, it is giving us some other information like it is a fat person, so its waist is increasing, its height is increasing, and its age is increasing. So it will tell us like that its weight is 90 kg, 95 kg. We will set out the boundaries. We can do it in regression. You don't need to exceed from this number. It is only used in some specific cases where, for example, we need to check out the GPA, right, or the marks percentage. It is not going to be increased from 100 and it is not going to be decreased from 0. So we can put the threshold over there, looking toward our output style, like what problem is and what will be the output against it. We can decide the conditions and threshold inside regression also. Regression we are going to use, the first of all, we have the simple linear regression over there. So it is the simplest type of regression in which we have one dependent variable and one independent variable, right? We have only one value. On the basis of this value, we are going to predict only one other value. Like it is used for predictive analysis, and linear regression is the linear approach for modeling the relationship between the certain or scalar response and the multiple predictors or explanatory variables. Linear regressions focus on the conditional probability distribution of the response given the value of the predictor. For the linear regression, there is a danger of overfitting. Yes, we will learn about what is overfitting here. The formula of the linear regression is going to be like the y is equal to b naught plus b1 and x1. So what are these values? First of all, y is the dependent variable. Dependent variable, or you can say it is going to be our output. Yes, so it is dependent variable y. It is depending on this formula, and after that, after doing calculation on it, it will provide few values which is going to be stored in the y, and which is going to be our output variable. So after that, we have the x, which is going to be the independent variable, right? So what x actually doing, x is the input that we gave to this formula to give us our output against it. So x is going to be the independent variable over here. So after that, we have b naught, which is going to be act like the constant in here, right? So after that, we have the b1, which is the slope or the coefficient value which is going to be inside our regression line. It is basically working for building the regression line inside our graphs that we will look in our future examples when we are doing it practically, right? In the b naught, the constant value, and the b1, which is going to be the slope for our regressor line. The motive is only for finding these two values. Against these two values, we are going to make our prediction that will look in our practical examples. So after that, we are moving toward our multilinear regression. So what it is actually, in simple word, I want to tell you that in here, just like the multi-class classification, we are increasing our classes, and just like that in multilinear regression, what we are going to do, we are going to increase our independent variables, right? So as you can see in formula, we have b naught, b1, b2 and bn here. These are in here we have x1, x2 and x up to nth base, right? So what actually x is? First, it is the first independent variable, and this is a second independent variable, and up to the last independent variable available inside our data. So let's move toward its definition and how it is working. So it is another type of regression in which we have multiple independent variable, just as I told you, and single dependent variable is going to be us, right? We are going to get only a single prediction out of it, what will be the result against these multiple inputs. Like multiple independent variable is going to be provided, and the dependent variable is going to be one out of it. All the independent variable are collectively given the prediction for independent variable, just like as this formula as I told you. And y is our dependent variable, which is going to be get a value out of this formula. I want to tell you one thing here. We can do linear regression only on linear type of data. What is actually the linear data? It is the type of data in which all the data is sequentially ordered. Like the continuously are sequentially ordered. That means the previous and the next value is going to be associated with our current value, right? So whenever we are going to graph it, it is only moving toward a single straight line that we will draw as a regressor line inside our graphs. So whenever we are going to use the non-linear data, these techniques are going to be not working in there, right? So for example, we have non-linear data, and I'm going to put inside the simple linear regressor or the multilinear regressor. It is going to give us the wrong predictions. That is not what we want from our machine learning model. So for prevention of that, we have another type of regression, which is polynomial regression. Of regression analysis, in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial in x. Just as I told you in our previous examples of regression, where this b is going to be construct our regression line, right? The b1, b2, b3, and the b0 is going to be work as the constant here, just like the previous. But here you can see a difference. What the difference? We have some nth degree polynomial values over here. As we are increasing our feature values, and what it is going to be working like, it is increasing its nth degree of polynomial. So in our multi-class, in our regression, simple linear regression, multi-class linear regression, multilinear regression, which is actually, so in here we are using a straight line, right, for our regressor line. But in here, whenever this polynomial degree is increasing, the curve of our predictor regressor is going to be increasing. Like let me explain by using some diagrams here. For the simple linear regression, you can check out here what actually we have in here. So in this graph, you can check out these green dotted, like this is the line which I am actually calling the regressor line, but the name actual term which is used for this line is least square line, LSL, like the least square line, which is going to work for our prediction over here. So right now on this line, we have the green dot over here, right? This is a scatter plot actually, and this is the green dot. What it is representing us. These are the linear values present inside our data, and these are the actual values which we use for our model preparation, model training. So here we can see it constructed a line on the basis of these values, right? So these are the red dot present over there. We have 1, 2, 3, 4, and 5, and here we have 1, 2, 3, 4, and 4 values over there. So we are getting 4 predictions out of there. So these red dots are presenting out the output, like the prediction outside our simple linear regression, which we get by using our simple linear regression model in there. So you can hear we have, these are the actual training data over there, and we have the prediction over here. We have a thing to note here: the distance from our this point to this line, this point to this line, and this point to this line is going to be equal to SSE, which is the error of sum of square, right? We will check out in our practical examples how we can find it between this regression line and this predicted point. And just like if we move below this line, So the distance from this line to this point is going to be equal to two terms for finding our r square value, which we will learn in our practical examples how we can find it and how it is going to help us. Whenever the smaller the value of SSR or SSE, the more accuracy the prediction will be, right? Whenever these values are going to decrease, we are getting more accuracy out of our model, so which would make the model the best fit, right? As you can see, we have a polynomial regression graph. Here we are using nonlinear data in our simple linear regression or multi-class linear regression over here. So you can actually see we have a straight line, the regressor that I told you, which is the least square line. It is not going to be best fit for this data because this is the non-linear data, because this data is not in the sequential form, right? So it is giving us too much least accuracy over there, and it is giving us the wrong prediction from it that we not need from any machine learning model. So for solving this problem, we actually used our polynomial regression model over here. As you can see, now our line is not in a straight pattern, it is moving with our data. So what is going to be happen over here, we are increasing our accuracy of outputs, like, right? So polynomial regression is going to work with non-linear data, and it is not using a straight line for giving prediction us in our graphs. It is actually moving it is a curved line. It can be a U shape or any other shape like here, and it will be in the curve shape because the data is not sequential. So that's why we are using the polynomial regression. So let's move and check out how we can code for our regression problems in our Python language. For that purpose, first I want to tell you something about the machine learning models. All the machine learning models are present inside a huge and massive and most important library of Python, which is scikit-learn. So I recommend you to install the scikit library present for our Python, on the basis of which we will do our model prediction easily. Whenever more lot algorithms are defined inside this library, whenever we are not using it, we need to do a huge hustle over here. We need to provide each and every mathematical operations inside here. We need to provide each and every formula that we need to do some prediction. Because we are doing too many things in there, then there is a case we can do errors inside here. So I will recommend you to use the scikit-learn library for machine learning algorithm. You can easily train your model over here. It provides too many functions for feature extraction, data splitting, everything that you would need to do before our model training. So let's move toward our console and code our first regression model. We are officially starting to code our machine learning models inside the Python. This is the Jupyter Labbook environment, which is I'm using with Anaconda, right? So first of all, I need to give a heading over here. We are actually going to start the supervised machine, right here, machine learning. Yes. So after that, first here what I'm going to do, the simple linear regression model we are going to perform by manually. Here we are not using any library which we can use for performing direct supervised machine learning. We will check out how we can perform the direct supervised machine learning like the simple linear regression by using our scikit-learn library inside our Python. So here I'm going to do simple linear regression. So we are going to do simple linear regression over here. So let's move and check what is the formula for it? As I told you, we can use it as the x is going to be equal with the b naught, and after that we can use the plus operator over here, and the b1 value, which is going to be the slope for our graph, and after that we will provide it x value, which is going to be a independent variable, right? So against it, you can also use another formula, which is going to be like the same thing, but the difference of few values like the mx and plus c. So here the c is acting like the b naught and m is acting like the b1, and x is the same as here, right? So let's move toward our libraries. First step is going to be importing libraries. Importing, I'm sorry, importing libraries. So here we go. First of all, which library we need to use? NumPy and Panda is the most demanding and the most useful libraries in machine learning. So that's why whatever we are going to do, we are using these values. Import NumPy, hit tab here, the NumPy as shorthand for NP, and after that I'm going to import our second library, which is the pandas, right? Pandas as PD, right over here. And the third library which I'm going to import here is the matplotlib, because we need to plot the graph of our linear regression over here, so we need matplotlib also over here. So for that purpose I'm going to import mat, hit tab, here we have matplotlib dot pyplot over here. Oh sorry, this is pylab, we need to import pyplot here, and I'm importing as plt, the shorthand for plt. Why we use this shorthand? Except of using this long term in our code, we are going to use simply plt keyword for calling this function or method inside a library. So we are using actually the shorthand keywords over here. So just like that, we have successfully imported our machine learning libraries that we need to use inside our data. And after that, the second step for this, first of all, what we are doing, we are importing our libraries. In the second step, we need to load our data. Assalamu alaikum. जी शुक्र अल्लाह का. We are going to load our data, because without data we can't do anything inside machine learning. Data is the necessary part in there. If we have no data, we can't do nothing inside. So first of all, I'm not using any CSV file or Excel or any other formatted file, built-in data assets. I'm going to drive my own data, because now we are not using any type of library, so we don't want to use a huge data set over here. So for that purpose, I simply use the data which is going to be like a dictionary formatted in there. So for that purpose, first of all, I will type a column name, which is going to be the X, and in this column I'm going to provide a list of values like 1, we have 2, 3, 4 and 5. Here we go. Let me format it, and yes, we have successfully created our first column, and after that you need to put the comma over here to separate this. So now I'm going to create another column which is going to be Y, right? Here I'm specifying the name of the column like X and Y, and after that here I'm putting values of this. So in this I am going to use some other values like the float values like 1.9, and after that we have 2.7 here, yes 2.7, and we can put 3.2, right, and after that we can put 2.5 and 5.1. Is these are equal, like the 5 and the 5 equal values over there, 1 2 3 4 5, 1 2 3 4 5, yes. And here we go, and we have created our dictionary type of variable with the name of data, and let's execute it, and now we have data over here, and let's check what we have. We have these two values like y, x and y, and inside these we have the values. Now and you need to check a thing over here. whenever you are going to do a model training on a data set, your data set must be in a data frame format. So for that purpose, we need to convert this data into a data frame. For this, I am going to use a data set keyword over here as a variable for data frame hour. For this purpose, I am going to use our pandas library, which is providing us a great method available inside here from which we can convert it into a data frame. That's I type data and I hit tab and it automatically completed it as data frame. So in this parenthesis, we need to provide the variable or the data set which we want to convert into our pandas data frame. So here we have the data and I'm going to put the data over here, and let's execute it and now check what we have the data in the data set. And here we go. You can see we have successfully converted our this dictionary of data into our data frame, which is data set. And let's check the type of this, is it actually data set or not. So it is going to be like the data set dot type. Can check the type of this, and let's we have the pandas.co the data frame the data frame. So we have successfully converted our this data of dictionary in Python, converted into inside a data frame. So let's move toward our third step, which is going to be like the EDA. Right here we will do some data analysis on our some data frame. So what is the topic for now? It is EDA, which is going to be like the data analysis for it. The data we have inside data set, we can check out it different type of attributes, how many unique values present inside there, what is the shape of it, what values present inside it. All these things we do inside our data frame, in which let me comment down here, we will check out the shape, check the shape of our data, and after that we can check out the information of our data, and after that we can check the missing values over here. Yes, the missing values also working in here to solve some problems according to our missing values present inside our data. And after that we can also check if we want to change the most repeating values, most repeat repeating values over here. And after that we can also replace the missing values, right? Replace missing values. Yes, here we go, the missing values. An important thing that we can do in our EDA is going to be like converting our categorical data into our numerical data. So what is actually categorical data? Whenever you are going to provide data to our machine learning models, it is not going to accept the data which is containing alphabets inside it. Like one row we have of name, which name can't be a number, right? So name will contain some alphabetic values inside it. Whenever we are going to provide these values to our machine learning model, it is not going to work with it. Before working with it, we need to change this data into some numeric format. So here we can also convert categorical data numerical data, right? In which we can use the one hot encoding technique, one hot encoding, which is the most popularly using technique for converting our categorical data into the numeric format. And besides this, we have different type of multiple techniques that we can use to convert our categorical data into the numeric data, right? So as you can see, we have created this data by own self, so we don't need to do too many modifications on it. This is the smallest data set ever, so it is not containing any categorical data, any missing value or any repeating value, so it is good fit for now. We are not going to do any EDA on it. So after that, the next step, the fourth step, which is going to for machine learning models, is data pre-processing. Data pre-processing. right? Some persons looks like tells that the EDA and the data processing is the same term. Most likely it is not the same term. Here what we are doing in pre-processing, we are splitting our data into testing and training data sets. We are extracting some features outside it, and these are the only things that we are doing inside. Even the things that we are doing in EDA are all these that I enlisted here, right? So let's move toward our pre-processing session. So here I want to convert this data frame, like we have the data set over here. I want to convert this data frame into x and y variables, in which x is containing few other values and y is containing few other values. I want to create a variable in which we have x separately and y separately. So let's comment down it to save some space over here. So for that purpose, what I'm going to do, first of all, I will type the y, which is going to be equal with dataset. Here we go, dataset dot I log, right? This function we will use to separate a specific column from our data frame. So now I want only y values in here. So for that purpose, I'm going to put the empty, because I want the whole rows out of it, and which column I want from it, the first column, right over here. It's so for that purpose I'm going to type 0 over here, dot values, because I want values outside this data frame. It will convert it into its numpy array. So what actually we are doing here, we are extracting our features, right? As I told you, in data preprocessing we are actually extracting our features. Like let me comment down here, extract features, and after that we can do data splitting here, over here, splitting, right? So here what actually I'm doing, I'm extracting my feature of independent variables, right? So after that let's move toward our y path from x, which is going to be equal like dataset dot ilog, and in this ilog session I'm going to choose our second column, right? So for that purpose I'm going to use 1 over here, and dot values for containing values inside our numpy array. So this is a numpy's keyword here, which is going to convert it into numpy array. So what here we are doing, we are taking our v variable or the responses in there. What actually we are taking inside it, the y is the values that we will give to the model, and x are the prediction over here, right? Here we have the values, and against it we have some predictions in the y. So here we have the predictor or our dependent variable, right?